Hello guys, welcome back to part 2 of Module 3 Lesson 2. We are looking at how to generate equivalent expressions, and we're rewriting our expressions as equivalent expressions. Now, in order to do the second part of this lesson, we need to have a review on multiplicative inverse this time. First, we looked at additive inverse, the idea that if I add the opposite, that's the same as subtraction. Well, we need to strengthen this idea that whenever I multiply by the reciprocal or multiply by the multiplicative inverse, that's the same as division. So the place you're going to be most familiar with this is maybe you remember doing some kind of fraction work like 1/2 divided by 3/4, and you may have used some, device like keep, change, flip or something like that to remember this. Well, it's important that we now move into a period where we understand the academic vocabulary. The keep, change, flip is a procedure, but the mathematical concept behind that is that anytime I multiply by a number's reciprocal, it's the same as dividing by that number. So to divide by 3/4 would be the same as multiplying by 4/3, and then I would just get like 4/6, that's my product here, or 2/3. But the concept here is that we want to go from procedures like keep, change, flip to proper academic vocabulary and conceptual understanding that when I multiply by the reciprocal, that's the same as division. So here's an example. If I were to divide by 3, that's the same as multiplying by 1/3, right? 1/3 of 12 is 4. 12 divided by 3 is 4. That's the same thing. So we're going to strengthen that as we go through this concept here. So the multiplicative inverse of 5 would be 1/5. So 5 divided by 1/5, or excuse me, 5 times 1/5 would be 5 over 1 times 1 over 5, and that creates 1. With additive inverses, we create 0. To prove that you have a multiplicative inverse, you would show that it creates 1. 65 divided by 5, that's the same as saying 65 times 1/5, which would be 65 over 5, which is equivalent to 13 over 1, or 13. Okay? -2. The multiplicative inverse of -2 would be -1/2, because -2 is 2 over 1, -2 over 1. So -2 times -1/2 would be -2, or actually, excuse me, it would just be 2 over 2, and that would be 1. We can see this used by saying 18 times -1/2 is -18 over 2, which is equivalent to -9. Here we see -3/5. Well, what would be the multiplicative inverse of -3/5? What would I need to multiply by in order to get 1? Well, -3/5 times -5/3. 3 times 5 is 15. 5 times 3 is 15, and that actually creates 1. This should actually go over here. I'm sorry. You can write that over here. The answer to that was -5/3. So in this box, just write -5/3. All right. 6 divided by -3/5. I can write that as 6 times -5 over 3. This would be -30 over 3, which is equivalent to, excuse me, -10. Great. Now we get to these variables again. We say, all of this, I knew how to divide. I can divide by 3. I can divide by 5. I knew how to do that. But now it's, how do we divide by x? How do we divide by 2x? And now we need to start to really use that conceptual understanding of multiplying by a reciprocal. So if I'm looking at x, what is the reciprocal of x? It is 1 over x, because x could be written as x over 1. So let's prove that. X times 1 over x is going to give me x divided by x. What is any number divided by itself? It's 1. The reciprocal of x is 1 over x. So it could be said that 5x divided by x is 5x times 1 over x, or 5x over x. And anytime I have the same factor in the numerator and the same factor in the denominator, those factors can cancel out or eliminate, and I would just get 5. 5 times x divided by x equals 5. Alright, the multiplicative inverse of 2x is going to be 1 over 2x. We can prove that by saying 2x times 1 over 2x is going to be 2x over 2x. 2 divided by 2, those eliminate to create 1. X divided by x eliminates to create 1. So now I've got 1 times 1 and 1 times 1, and that is just 1 over 1. It all simplifies out to 1. So let's look at this. 12x divided by 2x, that's 12x times 1 over 2x, or 12x over 2x. 12 over 2, that can simplify down to 6 over 1. X divided by x, those can simplify as well, and we just get 6 over 1. Alright, so it is important to remember that whenever we are dividing, we can write that as multiplying by the reciprocal. That's going to be instrumental throughout your entire 7th grade year and really continuing on into higher levels of math, algebra, algebra 2. It's absolutely essential for us to understand that conceptually. Okay, I want to show you some examples. I'm going to look at set 4 of your problem set. So if you'll skip ahead, according to my page numbers, we were on page 19, and we're skipping ahead to page 26. I want you to look at problem A of set 4, and we're going to just get an example. 8x divided by 2. That is the same as 8x times 1/2. To do that problem, I could do 8x over 2. 8 and 2, this is going to simplify. 8 over 2 simplifies to 4 over 1, and that's just 4x over 1, which is 4x. Alright, so that works nicely. And we'll do the same thing for problem C. 25 divided by 5r is 25 times 1 over 5r. So 25r over 5r. Well, r divided by r is going to be, they're going to cancel out. They're going to simplify down to 1. Anything divided by itself is 1. And 25 divided by 5 is just going to be 5. I could cancel that. I could show that up here. We could simplify, or we could just do 25 divided by 5 is equal to 5. All right, I want to show you a couple examples from your problem set that you'll be doing for homework, and I want to show you what it means with all this verifying. Let's make sure that we do that correctly. Okay, I am now looking at page 21, which is set 1 on your problem set. Part A, 3x plus 2x minus 4. When I do this problem, what I would like to do is rewrite all of this as addition, which gives me the ability to use properties like the commutative and associative property. I would like to identify my like terms. So here are my variable terms. I'm going to put a box around my variable terms. There's only one constant term. If there are multiples, maybe I would circle it. But I can add these two terms together. 3x and negative 4x is negative x plus 2. Now, we are asked to verify when x is equal to 5. What are we verifying? Well, what is our goal? What are we doing? What's the point of this whole lesson? And the point of this lesson is I'm writing equivalent expressions. That means that the expression I've written here is exactly the same as the expression I've written here. How can I show that that's true? Well, if it was true, I could put a number in for x and I would get the same value, right? If the expressions are equivalent, then when I put a number in for x, I get the same value for each expression. So let's do that. I'm going to kind of draw a line down the middle. I'm going to start with my original expression of 3x plus 2 minus 4x. That was my original expression. And then my simplified expression was negative x plus 2. And I'm going to verify when x is equal to 5. That means I'm going to substitute 5 for x. 3 times 5 plus 2 minus 4 times 5. And this is in parentheses. And that is 15 plus, well, 2 minus 20. 2 minus 20 is negative 18. 2 plus negative 20, that's negative 18. And 15 plus negative 18 is negative 3. All right, so when x is equal to 5, this expression should be evaluate to negative 3. Well, I have rewritten this expression as negative x plus 2. If that's truly an equivalent expression, when I put 5 in for x, it will also evaluate to negative 3. Let's see, is it equivalent? 5 in for x, so the opposite of 5 plus 2. Add those together, negative 3. I have proved, I have verified that this expression and this expression are equivalent because when I plugged in a value for x, when I substituted a value for x, I evaluated both expressions to the same value. Okay. I think that is sufficient for you. You're going to continue to do that throughout set 1, 2, 3, and 4, and you will verify your solutions by substituting in a value for the variable that will prove that both of your expressions are equivalent. All right. Thank you.